Why is it crucial to comprehend the nomenclature of alicyclic compounds? Well, every chemistry student knows the struggle that comes with understanding the numerous compounds and their names, but it's not just a nightmare intended to make studying chemistry harder. It's a precise system that, when understood, can reveal a lot about the compound's structure and properties. Alicyclic compounds are no exception to this rule. An alicyclic compound, to begin with, is an organic compound that is both aliphatic and cyclic. They contain one or more all-carbon rings which may be either saturated or unsaturated, but do not have aromatic character. Some examples of alicyclic compounds include cyclohexane, cyclopentane, and more. To identify these compounds, a keen eye is required. Look for a ring structure in the compound. This ring, however, should not be aromatic. The presence of a non-aromatic ring structure is the first step to identifying an alicyclic compound. Output. Moving on to the naming of alicyclic compounds, it's an orderly process, a step-by-step method that once mastered becomes second nature. The first step is to identify the parent chain. In alicyclic compounds, the parent chain is the largest ring. Next, identify the substituents, which are the groups attached to the parent ring. Each substituent is given a number, starting from the carbon next to the attached group. If there are two substituents, the ring is numbered so that these groups get the lowest possible numbers. After numbering, it's time for naming. Start with the name of the substituent, followed by the name of the parent chain. For instance, if a methyl group is attached to cyclohexane, it would be named methylcyclohexane. If there are two methyl groups, it would be named dimethylcyclohexane, and so forth. The last step is to include the numbers of carbon atoms to which the substituents are attached, using hyphens to separate the numbers and commas to separate multiple numbers. For example, if two methyl groups are attached to the first and second carbon of cyclohexane, the compound would be named 1,2-dimethylcyclohexane. To sum it up, understanding the nomenclature of alicyclic compounds is crucial for making sense of their structure and properties. It's a systematic process that involves identifying the parent chain, numbering the substituents, and naming the compound accordingly. Remember, the key to mastering this is practice. The more you work with these compounds, the more intuitive the process becomes. So don't shy away from those organic molecules. Each one is a new opportunity to hone your skills and deepen your understanding of the fascinating world of chemistry.